Hello, my name is Arthur, and in this video we're going to do some bracket highlighting. So yeah, we'll start off, we'll sort of look at how this one functions. This one will function if we put the cursor on either side of a bracket, and if we put it in between two brackets, it will default to the right hand side, unless the right hand side is an invalid bracket. So if it's an invalid bracket, it will then default to the left side and search that bracket out. We'll start off, that's the basic function that we're going to look for. It's good to note that these bracket searches are not always 100%. So like when we have a bunch of nested brackets and we break one of them, and then we look to highlight this one. If we'd broken this one, it's just going to highlight the next one. And that's the way that most bracket searches work. And I think that they follow the exact same type of algorithm that I've implemented here. I don't know, because I just looked at what was required to find the closed bracket. So that's where we'll start off, is we'll start off with the theory. And then we'll go over the already written script. So I've already got implemented bracket search here. So I'm able to search for brackets and find valid ones. Let's address the situation from I put my cursor next to this bracket. I chose this direction on purpose to illustrate that it doesn't matter what direction we're searching in. The math kind of works the same way. So this is the theory. We start with an integer. I called it mate because we're looking for this bracket's mate. It starts at a value of 1. So we have some fake script here. All of the brackets are completed, so this is a complete bracket set. We're parked next to a closing bracket. So when we park next to a closing bracket, that determines our search direction. So we're searching backwards for an open bracket. Mate starts at a value of 1. It searches upward, finds another closing bracket. So it adds to mate, making it 2. Searches upward, finds another closing bracket. Increments mate again up to 3. Searches upward, finds an opening bracket. So now it subtracts from that number to equal 2. Searches up, finds another open bracket. Subtracts from the integer to equal 1. Searches up, subtracts, it hits the number 0, and bingo, we found its mate. So that works no matter what direction we're going in. So we have an open bracket, mate equals 1, mate equals 2, mate equals 3, mate equals 2, mate equals 1, mate equals 0, and bingo, we found its mate. So that's just the simple math, and I'm pretty sure that would be exactly how this one is functioning. So we'll look at this a little bit further to get an idea what's required to be able to make this work. We might notice I'm moving my cursor around, but I'm not pressing any keys. So obviously this function is not getting called like other search functions are being called by the press of a key, because a key press might represent some manner of change. I press a key, I might be changing the nature of a word. But in this event, I'm moving the cursor, and moving the cursor either by keyboard or mouse click. So that involves having some cursor awareness. We have to make our software aware that the cursor is being moved to be able to do these things. So to do that, this function that's doing the highlighting of the brackets needed to be added to the H file so that main has access to the function. Inside of main, for the text buffer for each page, I'm adding in a notify cursor position signal. Now, I've looked up documentation for this. Well, I've attempted to look up documentation for this. The only reason I even found this signal was just I stumbled upon it in a Stack Exchange post. Other than that, cursor position can be found as one of the properties, I think it is, a property of a text buffer. But as for the signal, how to write the signal, and what parameters the function call would receive from the signal, I can't find any documentation on that at all. So when the signal gets sent, it gets sent anytime I move the cursor, whether it's by mouse or by arrow key or even by typing. This is going to get called. And, well, pretty much to the point that we could probably comment this out, because I don't think key release is actually relevant to highlighting lines anymore, because when we type, the cursor position moves, the signal is sent, and the first thing that cursor position does is highlights the line. So that's probably a function call that I'll comment out and see if we still function. But in case we need the example, I don't want to stop and erase that to experiment with that. So we'll just leave it as it is for now. But it's entirely likely that this function call is causing causing highlight line to be called twice when it doesn't need to be. So the reason I put highlight line into here is because I want it to be aware. So I want it to highlight the line, initiate the comment, and go exclude this bracket from consideration, because now that it's excluded from consideration, it won't highlight. Whereas if I comment out this one, we get the desired behavior. This has no mate, so it's now defaulting to the bracket that's behind it. So that gets all of the behaviors to function the same as it does in this software. So yeah, highlight line is quite probably being called twice, and that's something that needs to be corrected in my own script, and I'll comment that out later and see if everything works the same, which I anticipate it will. So to go along with the cursor position function, I've also written a convenience function. So it's up at the top, it returns a Boolean, and I called it included. So the idea of the name is, should this character be included in the search for a bracket? So what it gets sent is the iter that got the character that's under consideration. And I've initialized the different kinds of tags that I want to be excluded from consideration. So if a bracket's inside any kind of a quote or any kind of a comment, it shouldn't be considered a bracket. It's either a white space in the event that it's in a comment block, or it's a string or a char. So if it's in any of those, the function will return false and it will be excluded from consideration. Otherwise, it returns true and it will be included for consideration. So current tab, page number, that's all very standard. We use the mark because I can't find parameters for the signal to say where the cursor is at, so we need a mark to get where the cursor is at. Temp right and temp left, those just hold the char for the itters that will get the char on either side of the cursor. So we want to be able to consider this char and this char when the cursor is between them. And in any event, we want to be able to consider things that are on the left or right of the cursor anyways. So those are to hold that. Add and subtract, that's when it comes to should we add to mate or should we subtract to mate? So add and subtract are basically we're assigning the values of chars. So if we're searching for this char, our subtract char would be its opposite, and this would be our add char. The integer for bracket right and left, this is in lieu of using a Boolean. So it starts off as false, but it can have true of different meanings. So we use an integer instead of a Boolean because we want true of different meanings. So the different meanings would be an open bracket. Well, that means, okay, the bracket is true with a forward search. Whereas if we were looking at a closing bracket, we would be true with a backward search. So we can do that with an integer, but we can't do that with a Boolean. And that's part of the reason that Booleans aren't actually a part of C by default. You have to define a Boolean for it to exist in C. So the mark is used to get the insert. The insert is where the cursor is at. So we get the mark so that we can place the right iter at the cursor. So right iter at the cursor, it gets what's on the right of the cursor. We initialize the start and stop iters because we have to have a start to our page and an end to our page. So that's the start of the buffer, that's the stop for the buffer. Declare and initialize our color tag. So our color tag, we've done lots of color tags here. The only difference is I used a purple with a background because I want it to highlight instead of just change colors because it stands out more. So I like it. I like it where it highlights rather than just changes color like this one. So we create our tag, we remove it from the entire page. If the left iter is sitting at the start of a line, so if the left iter is sitting at the start of a line, there's nothing behind it. So right and left are sitting in the same place right now. There's nothing behind the left. There's nothing for the left iter to look at because it's at the end of the line. So if it's not at the end of the line, it's not at the end of the line. It will move backward a cursor position and get the char. So the cursor is here. Left moves back, gets the char. That's on the left side of the cursor. The same thing with the right iter. If right iter is at the end of the line, there's nothing in front of it to get. If it isn't, it can just get the char because it's already sitting in the right place. It doesn't need to be moved to get the char. So those are being assigned to temp left and temp right. So we look at temp left and temp right, and we decide should they be included in the search. So if they're in a bracket or a comment block, they should not be included. It falls through. And it doesn't do any comparison at all. So we have the cases. We can see here I've included the three kinds of main brackets, but I have not included minus or less than and greater than as brackets, and I'm not going to. It's not likely I'll include those. I don't think they're a major part of brackets in C language. They might be in other languages, but not in C, not so much. About the only place I know we use those as a bracket, the only place I've ever used it is with an include. So when we get the cases in open bracket, we set the integer for bracket left to be 1. So 1 means a forward search. We set the subtract char to be its opposite. If it's a closing bracket, we set the value of 2. That means it's a backward search. We set its opposite or its counterpart as the subtract char. And that pattern is followed for any of the bracket types. And for the right side, it's all exactly the same. So it follows the exact same pattern, and we do the exact same thing. We assign the opposite as the subtract char. We give it a number to determine the search direction. So those are just considering for either side of the cursor. That way, that gives us the ability to search on either side of the cursor. So we get to this point, bracket R or bracket left. If we remember, these are integers. So if it still equals 0, it's just going to fall through. So neither one found a bracket. So that would equal 0. When the cursor is here, that's 0. It falls through. It doesn't do anything. If one or the other equals 1, it will address the right side first because that's the default. So we address the right side first because it's the default. If it doesn't find a mate, it will then search the other side of the cursor. So we put iter at the position of the right iter. And maybe iter wasn't the best choice of my different global iters, but that's the one that I use. So try not to let that be confusing. It's just the name of one of the iters, one of many iters used in this script. We set the value of mate to 1, while bracket R has an integer value of 1 or 2. If it has a value of 0, it doesn't do anything. It falls through to bracket left. So while bracket R has an integer value, it's either 1 or it's 2. We check for an offset if it's 1, which is a forward search. So we're looking if the offset between the searching iter is 0. That means it's at the end of the buffer, so it would break out. Otherwise, it goes forward a cursor position. If the value is 2, that means we have a backward search. It's moving towards the start. We check in the offset because if it's 0, we're at the edge of the buffer, and we don't want to look for chars outside of the appropriate memory range. Otherwise, it moves backwards a cursor position. We get the char. We compare it. Does it equal the add, which we assigned up here? Add would be this bracket. So if the case was that, subtract became its opposite. So that's add and subtract as chars. So if temp equals add, it will add to mate. If it equals subtract, which is the opposite of what we're searching for, it will well, it's the opposite. It's the close or open bracket to the bracket where that's under consideration. Sorry, that's a little confusing to say. At the same time, it's checking if these should be included. So we're checking, are these inside of quotes or comments? So when it comes across one that equals subtract, it will subtract from mate, and when mate equals 0, it will move iters around. End will be where right is. We'll move end forward 1. That way we have right and end. We can apply our tag to right and end because they're on either side. We move the hold iter to where iter is at. So iter would be at the result. We move hold here, move it forward a cursor position, so we can use iter and hold to apply the tag. If none of that happens, it will come down and do the left. And that would be in the event that it's between 2 or it only has 1 to its left. And this entire function is entirely the same. The only difference is the word left. So the values are the same. If bracket has a value of 1 or 2, it's going to move forward, backwards. It's going to check against whether it's hitting the edge of the buffer or not. Get the char. The math is all exactly the same because we set these values up in the switch. So it will add or subtract until it equals 0. If it can't equal 0, it will fall out without finding a match. Yeah, even on the left side, the iters are moved exactly the same way. The tags are added exactly the same way. The difference between the left and the right is so small that I could question whether these could actually be integrated into a single while statement, which is entirely possible. It's entirely possible that having the 2 blocks is actually unnecessary. But when I'm writing things out, I'm not able to complicate them that much to be able to slim down the script. First, I have to get it working in the less complicated form to be able to merge it into the more complicated form. So I hope that explanation of this function is clear, and the explanation of just the general theory is clear. And yeah, that's it for this video. In the next video, I'm likely to come back and address these horrible, horrible tabs that we get by default inside of a text view. So maybe get these tabs down to a proper size, maybe like 2 or 3 spaces, and maybe introduce some tab awareness so that our cursor ends up where it should have ended up, considering the tab of the line above it. So maybe something along those lines in the next video, and we'll see what I can figure out. And until then, I hope this was clear and useful, and take care.